Now let us see the interpretation of units. For example, we'll consider some formulas from our torsion chapter. The torsional shear stress formula is given by tau is equal to T multiplied by R divided by J, where T is torque in Newton mm, R is radius in mm, and J is polar moment of inertia in mm raised to 4. Mm multiplied by mm is mm square. J is in mm raised to 4. So mm square and mm raised to 4 will get Newton per mm square. So that will match with the unit of the shear stress, that is Newton per mm square. 1 MPa is 1 Newton per mm square. Polar moment of inertia for a circular shaft is having the formula of pi by 32 d raised to 4. Pi and 32, they are not having units. Diameter is in mm and raised to 4, so it is mm raised to 4. So we can say that polar moment of inertia is having unit of mm raised to 4. Power is in watt or joule per second. Now power is given by torque multiplied by angular velocity. Torque is in Newton meter and angular velocity is in radian per second. So it is Newton meter per second. Radian, it is the angular unit. We are not considering that. Then Newton meter is nothing but joule. So it is joule per second, and that is nothing but watt. Another formula for power, which is expressed in watt, is 2 pi T multiplied by N divided by 60. Now here important part is that this revolution per minute is converted into revolutions per second by dividing by this 60. So 2 pi and this 60, they are not having any units. So Newton meter as it is, and revolution per minute is converted into revolution per second. So again, revolution is the circular unit. We are not considering that. So we'll be left with only Newton meter per second. Newton meter is in joule. So it is joule per second, that is watt. Maximum shear stress, the units of shear stress already we have seen. It is the same interpretation. Mm multiplied by mm, that is mm square. Newton as it is, J is in mm raised to 4. So mm square and mm raised to 4. So it is Newton per mm square. Polar moment of inertia of a hollow circular shaft. So formula is pi by 32 do raised to 4 minus di raised to 4. Diameter is in mm. So here also inner diameter, it is in mm. So mm raised to 4 minus mm raised to 4. So unit is mm raised to 4. Plus or minus will not have any impact on the units. So only mm raised to 4 we have to consider. That will get matched with our left hand side unit. Suppose we consider the bending stress formula, that is given by sigma b is equal to m into y divided by I. So m multiplied by y divided by I. M is moment in Newton mm, y is the distance in mm, and I is the moment of inertia in mm raised to 4. Again, mm multiplied by mm is mm square, and mm square and mm raised to 4, that will get cancelled out, and in the denominator we'll have Newton per mm square. So where sigma b is the bending stress, m is the bending moment, y is the distance from the neutral axis, and I is the moment of inertia. Now, moment of inertia for rectangular section is BD cube by 12. B is width in mm and D is depth in mm. So D cube is there, so it is mm cube. So mm multiplied by mm cube, that is mm raised to 4. For circular section, it is pi by 64 D raised to 4. Pi and 64, they are not having any units. So diameter is in mm. So diameter raised to mm raised to 4. So unit of I is in mm raised to 4. Similarly, Z is the section modulus, which is expressed in terms of mm cube, that is I divided by y, where I is the moment of inertia and y is the distance. Moment of inertia is in mm raised to 4 and distance is in mm. So mm raised to 4 and 1 mm will get cancelled out, and in the numerator you will have mm cube. For rectangular section, it is given by BD square by 6, where B is the width in mm and D is the depth, and as the square is there, it will be in mm square. Mm multiplied by mm square, that is mm cube. Then section modulus for the circular section is given by pi by 32 d cube. d is in mm and cube of that, so it will be mm cube. So unit of section modulus, again it is in mm cube. Now maximum bending stress is given by m upon z. Just now we have seen that z is always expressed in terms of mm cube. Moment is in Newton mm. So mm and mm cube, the 1 mm will get cancelled out, and so you will get the unit of Newton per mm square. Then flexural formula is expressed. So each of these particular terms are sigma b upon y, m upon I, and that is equal to E upon R. So this is the flexural formula. Let us see each and every term separately. So bending stress Newton per mm square, distance is in mm. This mm square will come in the denominator, so it will be Newton per mm cube. Then moment is in Newton mm. I is in mm raised to 4. So mm raised to 4 and mm, 1 mm will get cancelled out. You will get Newton per mm cube. Mm square into mm, that is mm cube. So it is Newton per mm cube. So you can see that the equality sign is there between all the terms and the units are also matching.